Hey sunshines! I wanted to do a quick review on similarity. So I have two triangles here and they look like they're about the same shape, right? So what transformations happened here? It gets smaller. So it's a dilation. It's a reduction because this triangle is getting smaller if it maps onto this triangle. So if I take this as my pre-image, then I'm doing a reduction. So I'm doing a dilation by a number that's smaller than 1, a positive number smaller than 1. And I'm also, it flipped over, so it's a reflection. To show that they're actually similar, I need to know that it's truly the same shape though. So there's 3 ways that we can prove that two triangles are similar. I can prove that 2 of the angles are the same. So if I'm given that, let's say this is a right angle and this is a right angle. So angle B and angle Y are congruent angles. And angle C and angle X are congruent angles. Then I would have angle similarity. Now, you're not always going to be given clean, easy angles like that. Usually you'll have to figure something out. So maybe I'll give you that they're right, that these two are right angles. This one is, let's say this is 50 degrees and this is 40 degrees. Well, I could solve for the third angle of one of those triangles and so 40 plus 90 is 130. So I subtract 130 from both sides. And X equals 50. So I just solved and found that this angle is 50 degrees. So now I have angle similarity because I showed that angle X is congruent to angle C. What's wrong, little munchkin? All right. For side angle side similarity, you have to know the side lengths for 2 sides in each triangle, and you have to know that the angle connecting those 2 sides is congruent to the angle connecting the 2 sides of the other triangle. You also have to show that those sides are proportional to each other. Just knowing the lengths doesn't mean that it actually works. So you have to set up proportions and prove that those 2 fractions are actually equal to each other. So I know that angle B is congruent to angle Y. And so 3 and 2 are the smaller of the 2 sides that I know. So I'm going to do 3 over 2. And then 6 over 4. And I'm proving that they're equal, so I don't know that yet already. I have to show it. So I'm going to simplify those fractions. Well, 3/2 is simplified. They're both prime numbers, so I'm not going to get any simpler than that. But 6 and 4 are both divisible by 2. So half of 6 is 3, half of 4 is 2. Which is in fact equal. So now I know that my 2 pairs of sides are proportional. They have the same scale. This triangle is 3/2 the size of this triangle. You can flip it and you could say that this triangle is 2/3 the size of this triangle. I just chose to set my fraction up starting with this one on top. That's just the easiest way for me to keep track and not mix up what I'm doing and accidentally flip one of my fractions along the way. I always start, if I have a left and right, I start with the left on top and the right on the bottom. If I have top and bottom, I do the top one on the top and the bottom one on the bottom. It doesn't matter what order you do it as long as you're consistent. So I had this triangle was my numerator and this was my denominator. And then our last one is side, 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 which is really similar. Sparkle star. Plop. Go over there. He wants to watch and learn math. All right. So for side, side, side similarity, you're still doing proportions. This time you don't have any angles. You're using all three sides. So you have to have three fractions. So I'm going to take, I already did these two, so I'm just going to keep that work there. But I just have to add the other pair of sides. So 9/6, which they're both divisible by 3. So that's going to simplify to 3/2, which is equal. So I showed that they are similar by side, side, side similarity. So once you show that that two triangles are similar, then you have to make a similarity statement. So a similarity statement is when you say triangle whatever is similar to triangle whatever. The trick is that you have to make sure that you get the letters in the correct order. So the first letter in each triangle is the corresponding angle. The second letter in each triangle is the corresponding angles. So it doesn't matter what order you write the first triangle in. Triangle ABC is similar to triangle. What matters is that you match it up. So if I started with A, it's a reflection, right? A is between the middle side and the long side. So I have to go look for what letters between the middle side and the long side on the other triangle. So 4 and 6. So that's going to be Z. And it helps if you look at the transformations because it's a little easier to see, okay, it's a reflection. A goes with Z. Than it is to sometimes try and match up, okay, this is the long one and this is the short one and this is the angle that's between. And then B goes to Y. So C goes to X. So triangle ABC is similar to triangle ZYX. If I wanted to put it in a different order, I can totally do that. Thank you, Zoe. I want to put it in a different order. I can totally put it in a different order. I can do triangle, let's say, BAC is similar to, then if I'm starting with B, I have to start with Y. A goes with Z, and C goes with X. So it doesn't matter what order you put the first triangle in. All that matters is that the second triangle, you match it to the same order. So where's my eraser? And then our last thing is once you have two triangles, you know that they're similar, you just want to find the scale factor, or you want to solve for a missing side. So maybe I want to find, I don't know how big this side is. I want to find it. So we'll call that, what's a letter that I didn't use already? Let's do S for Mrs. Salazar. Hi, Zoe. Zoe, can you erase it after I'm done doing math? Here. Can you, Zoe, can you go find me a heart? Can you go find, all right. So I want to find S. So I'm going to do the same thing we did when we were proving that they were similar. This time I know that they're similar. So maybe I'm given the angles. So I have angle similarity. I know that the triangles are similar. Zoe. So I want to find S. So I'm going to set up the fraction using the corresponding sides. I know that 3 and 2 go together. I already know that they are similar, so I know that any pair of sides has to be equal to any other pair of sides as a fraction. So 3 and 2 go together, and then obviously I need one that has S in it. So 6 is the one that goes with S, so it's going to be 6/S. And so now I have a proportion. I have two ratios that are equal to each other. So now I just cross multiply to solve for S. So I have 3S equals 6 times 2 is 12. And then I'm going to divide both sides by 3. So that was cross multiply. Now I'm going to divide by 3. And I get S equals 12 divided by 3 is 4. And of course, that was the number that we used before when we set up our side similarity example. We know that was the side that actually made them work as similar in the first place. Also, if you're finding the scale factor, you need to just know scale factor is that pair of sides that work, that pair of sides we used as our reference. You take any pair of sides that you do have the values for, and you make a ratio out of them, and that's your scale factor. The only trick is that if you're looking at a dilation, you need to know which is the pre-image and which is the image. So I set it up as 3/2. That means I'm saying that this one is the image. Whatever one you put on top is your after. So if I want to say that this is my original triangle, what do I multiply it by to get the smaller triangle? Then I have to flip it over. You have to put your image on top over your pre-image. So that's after over before, which is a little bit counterintuitive, but it works because you're multiplying it. So the idea is that you end up wanting to cancel out your before triangle to get your after triangle. So, for example, if I want to say that this is my before triangle, what do I multiply this triangle by to get this triangle? Then I have to do 2/3 because 2 is my after, my image, and 3 is my before, my pre-image. And then I can take that scale factor and I multiply it by any side length on the before triangle to get the value in my after triangle. So I would do 2/3 times 6 equals 4. And that's how that's the other way that I could solve for S. If I calculate the scale factor and multiply it. It's a little trickier to keep track of the befores and afters that way. That's why I prefer doing it as a proportion so that you're cross multiplying. But you end up doing the same thing. 2 times 6 is 12. 12 divided by 3 is 4. Have a good day, sunshines.